The next test is on the two chapters, 4 and 5. The review, this is one of the problems, similar to one of the problems right here. Okay, we have c squared plus 10c plus 16 is divided by c plus 8. What are you going to do with that? You put this on the outside and you're going to divide, long division, right? Does that look familiar? Just something you've been doing? Okay. How are we going to get that first term? C times C gives us c squared. Multiply plus 8c. What are we doing here? We're subtracting, right? Show your subtraction. When we subtract, we end up adding the opposite of each one of them, right? So, that's gone. You mark it out or leave it, it doesn't matter. A 10 and a negative c, negative 8, so what is it? 2c. Okay, how are we going to get this? Positive 2 plus 2, okay, times the c, times the 8. It's going to all cancel out. We have no remainder, right? So what's our answer? C plus 2. Okay? Questions? All right. An envelope is 5 centimeters longer than it is wide. The area is 104 square centimeters, find the length and the width. Okay, what do we know about the length? It's longer than the width, right? How much longer? Okay, the length is the width plus 5. Right? Okay, we know what the area is, right? What's your formula for area of a, what shape is an envelope? Rectangle? What's the area of a rectangle?
Length times width times height.
That's volume.
Oh, that's volume.
Length times width is the area. Yeah. Okay. Instead of L, we're going to put this. Do we know the area? 104. Instead of L, we're going to put what? This. Okay. So we have W squared plus 5W. And we're going to run it equal to 0, aren't we? Can we skip the step of subtracting this? No, we better not. Let's go ahead and do it. Subtract it, and we'll put 0. You're probably not going to do all this work, are you? You're going to say, I know we're going to multiply to give me 104. So you could do 1 times 104, 2 times 52, and you could have done this without even getting to here, huh? If you know it's 5 longer, you're just going to keep going until you find one that's 5 apart, right? Okay, 3, 4, we'll go 26 times, that's not 5 apart yet. 5 won't go, 6. Will 6 go? No, because 2 and 3 don't go. Remember the divisibility rules? 2 and 3 both have to go for 6 to divide into it. 7? 70 leaves 34, no. Okay, 8. I think 8's gonna go into it. Because you do 8 from 10 is 24, there's 2, bring down to 4. 24 is, goes one time, you want to do that division, instead of me making you do it in your head. 8 into 10 is 1, bring the 2 down. 8 into 24, there we go. 13, those are 5 apart. To get a positive 5, you need positive, negative, right? Minus 8 plus 13. This gives us a width of 8. This gives us a width of negative 13. Can't have a negative width. And the length, you're going to add 5, which is your 13. What is our units on this? Yeah, these are centimeters, so these are centimeters. I don't know that it'll make you do that, but it'll probably already have centimeters written for you. Okay? There's that problem. Solve. You probably have a couple of them where you have to solve for a letter. You can actually just trade these, can't you? Let's show why we can trade those. Okay, if we have this, to get rid of the fraction, we multiply by h squared, right? Then you have h squared v equals this. And then how do we solve for h squared? This is multiplied, divide by v. So it traded those two, didn't it? The v went down there, h2 went up there. So if you know it can do that, you can actually just trade those and solve for h squared. Did you see how it did that? Yeah? Are you paying attention? Yeah? Okay, let's factor. What's the first thing you look for when you're factoring again? No, first thing. Common factor. There is a common factor, there's an S. Yes, let's take that out of there. 36 what? S squared. And now what'd you say again? Difference of squares. Because these are now squares. That one, they weren't squares right there. So this is 6 what? 6s. 7, and you have the plus and minus. Give you time to write. It says we have a moving sidewalk. That's kind of like having a current or a wind speed. That moving sidewalk is going to either help you get there quicker or you're going to be walking against it and it's going to take you longer because somehow you got on this walking thing and it's pulling you back, but you got to get to the other end and you got blocked in, so you have to walk. So not too many people walk against a moving sidewalk, but I guess it could happen, huh? Okay, let me get a paper because this doesn't leave me much room to do this. Okay, the moving sidewalk is going at a rate of 1.3 feet per second. And walking on the moving sidewalk, a person travels this far forward in the same time that it takes to travel this far in the opposite direction, so against it. how fast would the person be walking on a non-moving sidewalk? Or if you had an odometer, or a speedometer on your hip and it said how fast you were going, that's what it's asking. How fast are you walking? What's the rate of your walk? Okay. So, what is the same? We have distance, rate, time. The distances are different. The rate's the same, isn't it? Oh, yeah, it's gonna be, yeah, you're gonna have to add to the rate and subtract from the rate, right? Okay, so if the distance is not the same and the rate's not the same, what's the same? Time. In the same time, right? So the time is equal to the time. So the time going forward, the time going, let's put back. I don't want to put opposite because it looks like a zero. Okay, so what was time equal to again? We have distance is the rate times the time. Solving that for t, you divide by r, right? So time is distance over rate, right? Okay. So, what was the distance going forward?
106.
Right. 106 feet. And the distance going the opposite direction, 53. Okay, we have rates here. Okay? The rates will be the rate plus the sidewalk or the rate minus the sidewalk, right? When you're going forward, is that rate adding or subtracting from your, you're going faster, right? The rate plus, what was the speed of the sidewalk? The speed of the sidewalk is 1.3, so we need to put that on there. And going the other direction against the sidewalk, you're subtracting how fast it's going. Okay? So, the cross products are what? This is a proportion, cross products are, come on. Equal, there you go. Cross products are equal. So this times this is equal to this times this. Minus. Go to put the point. Okay?
That's supposed to be 104.
What? What should be yours? 104.
Oh, that's my bad. Never mind.
Okay. Multiply. 53R. What's 53 times 1.3? 68.9? Okay. 106R minus, say it loud,
130, negative 137.
137.8, is that right? Yes? I didn't do it, so I'm going by your word. Okay. Just trusting you. Here's an R, here's an R. Why don't we subtract this one instead of making it negative? So we've got 68.9 equals, what is that? Huh? 53? Okay? Now we're gonna solve it. We need the number over here, right? Plus 137.8. So that's,
206.7.
okay, divide that by 53 for me. 9?
3.9.
Oh, I was like, wow, it came out even? 3.9. So what is R? R is how fast you're walking, right? So that is what it was asking for, right? How fast would a person be moving on a non-moving sidewalk?
2.6.
On a non-moving?
Yeah.
2.6?
Yeah, because you go 3.9 minus 1.2, right?
That's how fast you'd be walking on a moving one.
No, it's... Goes to 5.2?
This is how fast he's walking. This right here is his speed. Like, if you were in a boat and the boat says you're going 10 miles an hour, but you're going against the current and it's actually pulling you back,
Yeah.
you still go by the speedometer.
Okay.
Yeah. If it asks you how fast is he moving, is he walking on a moving sidewalk, then you would have to either add or subtract it. A non-moving sidewalk is his speed of his walk.
Oh, okay, so it's 2.9.
See, you might have missed that on the test if we hadn't went over it, huh? You might have added or subtracted it thinking it was, all it wants is your rate of walk. So don't do anything to it. Leave it just 3.9, right. Okay, everybody get that?
So, even,
Yeah, that's what it wants. It wants R. It doesn't want R minus or plus. Okay, this is just subtract. Subtracting polynomials, just plain simple. We're not even doing this one yet. I knew it was going to be short, so I put more than one on a page here. Okay, if it says subtract, what are you going to do with that? You're going to change it to addition, right? Which, you change it and change every sign within the parentheses, and you'll be able to just add everything. So we have, let's start with the C cubed.
so that one cancels.
Oh, cool. Positive negative 1 goes away. C squared, 8 and negative 12. Negative 4c squared. And how about the c's? We have a positive 12 and a negative 4.
Plus 8.
Plus 8. C. And they're just wanting us to add and subtract, no factoring, none of that fancy stuff. All it wants you to do is that. So don't overthink it and think, okay, that's too easy, I should have done something else. That's all you have to do. You miss it because you'll overthink it, huh? Okay, there'll be a problem like this on there. It's, yeah. If it's f of x equals x da-da-da, it should say if I'm an x, so that f of x is something, but it's worded wrong, so don't let that mess you up, okay? They should have put x's here or had a's up here, okay? Don't let that mess you up. Just assume this is actually an x and it's wanting f of x equals 3, okay? So find it where this is 3. So all you're going to do is put 3 here and write the problem down. Okay? So how are we going to solve that? We need it to be equal to 0 so we can factor, right? So how do you do that? -3, right? Now you can factor and you can get two answers. Which factors of 24 add up to 11?
8, 3.
Yep. And if they're added to get a positive 11, what's the signs? Positive, positive, right? Positive 3 and positive 8 add up to 11? Okay. This one gives us the answer of what? -3. This one gives us the answer of what? -8. There's no denominators to have to make sure that it's okay. These are okay to put in here. There's no problem there. You got two answers. Okay?
How do you put the answer in?
With a comma.
You gotta put parentheses or no?
No parentheses. Do not put parentheses because that makes it a coordinate, like graphing. This is how you put your answer. -3, comma, -8. Okay, this is a mess, I'm sorry. This was so blurry and I started to put a plus, so I just marked that out. And just went from there. Okay.
Minus,
That's a minus. So what do we do with this? When you add fractions, you need what? You need a common denominator when you have fractions. We do not have a common denominator, I don't think, because they're not exactly alike. But to get it, we need to factor them, right? So factor this and factor this. This one's a difference of squares, right?
3 minus 2 equals 2.
Plus 2 minus 2. So that's not there anymore because it's this now. And this is these. And the factors will subtract to give us 6. 2 times 8. 2 and 8 subtract to give you 6. We need a -6. Biggest one needs to be negative, right? Okay, -8, positive 2. Okay, so what is our common denominator?
Plus 2.
Yeah, we need a plus and a -2, don't we? And we already have a +2, so we don't need that. We need the v minus 8 also, right? Plus and -2 and subtract 8. So we've got all those. We need to write down what we already had on top. Okay? And now we need to write down what we had to multiply the bottom by to get the common denominator. So what did we need to multiply this by?
What, b minus 2?
V minus 2. So the top is times V minus 2. You have to put this in parentheses because the whole thing is multiplied. You're going to have to FOIL it. Okay, so V minus 2 on the top and bottom. What do we multiply this by?
b minus 8.
Minus 8. So parentheses around it.
cancel with b -2.
No, don't cancel because you're in the, where you started. No, no canceling. We're going to have a common denominator, and we're going to do all that stuff. We have to, it's going to be long. We might be able to cancel at the end, but we may not. Okay, FOIL, 7b squared minus 14b, that's the outside, minus 1b And what about last times last? Plus 2. Minus. This is where it comes tricky. You're subtracting this whole thing. Okay, when you're subtracting this whole thing, when we FOIL it and write it down here, let's leave it in parentheses for now, or brackets or something now, so that we remember to change all the signs. Don't try to do it at the same time. FOIL it first and then go back and change signs. So first we're going to FOIL v squared minus 8v minus 5v plus 40. Okay? Now go back and change the signs. You're subtracting this whole thing. So add the opposite, 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 opposite. Guess I'll go ahead and write my common denominator while you guys are writing. Okay. Now you're going to add like terms on the top. V squared, you've got 7v squared and minus 1v squared.
That's 6v squared.
6. 7 minus 1 is 6. And we've got a lot of these here. Those 2 and those 2. These 2 add up to negative 15. These 2 add up to positive 13, right?
Negative 2.
Right. Negative 2v. And the numbers?
Minus 38.
Negative 38, right. So we've got that. Actually, I wrote down what the answer is, and miraculously, they don't factor 2 out of the top. So, normally you would do that, wouldn't you? To see if you could factor and go on, but they actually left it like this. Normally we would have went like this. 38 divided by 2 is 19. But there's no way to subtract to get 1 with 19. Anyway, if you have one like that, it's probably not going to factor. So don't spend all night long or whatever, morning or whenever you're taking it, trying to figure out if that'll factor so it can cancel. You know, just, you can save it till last if you want. Don't put that answer and put it off to the side and say, okay, don't forget to input this. Okay? But that's the answer they gave right there. This one actually had a graph with it. Had this big old long polynomial function, and it says that the time is going to be greater than 0, so it starts at 0 and goes all the way up to 6 on the graph. So if you actually saw the graph, I didn't have it drawn out, the t down here started at 0, went 1, 2, 3, 4, 5, 6. It went all the way up to 6. Okay? And I don't remember exactly what it looked like. Let me see. I know there'll be one like it up here. Anyway, it has a graph here. It tells you that this is a graph of how much. It starts out that there's not anything in your system when you take the pill. This is a graph of after you take 400 milligrams over a period of time, how much is in your system. And it kind of went up and then went down. Okay? After 6 hours, there was still some in your system, but probably not much. Okay, so what it first tells you to do is use the graph to estimate the number of milligrams after 5 hours. Okay? And when you do that, what you do is you go up, straight up from the 5, and you say, okay, where is that? And you're going to have numbers over here. So you say, okay, and it doesn't fall exactly on a number, there could be all kinds of numbers that you could put there, but it actually tells you to go to the nearest multiple of 40, so you can get the exact answer they have in there on the test. So you go there and you say, okay, that looks like about, make sure it's to a multiple of 40. Okay? I think the answer to this one, I didn't write it down. I think it's like 80 or something like that. I don't remember what the numbers were over here, but it was obviously a multiple of 40. It wasn't like 340 or 320 or whatever. It wasn't. It was a smaller number. Because you only start with 400, so it can't be very high over here, where it's dropping down. So it had you do that, and then it actually has you do like using the formula. It wants you to tell what would be in there after like 3 hours. So what you do on this one is you stick it in your calculator. Everywhere there's a T, you put a 3. So you just put this whole formula, that whole thing, in your calculator using the 3 here, put the exponent. You have to type all that in your calculator. You know how to do that, right? Yes?
On the like the yellow calculators,
Mhm.
for T, would it be the same as putting like an X there?
Don't put a T, put 3.
Oh, yeah, well, okay. Never mind.
Yeah, don't put any letters. It will have the 3s right there. Yeah.
So basically, I'm tired.
We're not graphing it. We don't have to put an X. I mean, if you wanted to make a graph, you could do that, but nah, it doesn't make you graph it. Okay, that's all I had written down, but that's not the only problem. So let me go through here and write some more. This looks like divide. We haven't done a divide yet. Okay. Z squared, that's a Z. Almost wasn't a Z. Okay, divided by 2Z minus 8 over Z squared minus 3Z minus 18. Okay. What I like to do as a visual, just to make sure I don't forget, I like to put that I'm going to be flipping this one over. Because when you divide by a fraction, you multiply by the reciprocal. So I like to circle that so I don't forget when I bring it down here that this one's going to end up on top. And to make sure I don't forget, I start right here. I start, okay, this is going to be on top, that's going to be on bottom. This one's easy to factor, so let's stick that on bottom. How can you factor this one? Common factor of 2. So Z minus what? 4. So there you won't forget to do it now. You've already got that down there. Let's factor that one. We have a Z and a Z. 18, 1 times 18, 2 times 9, 3 times 6. Which one subtract to give us 3? 3 and 6, right? We got our 3 and our 6. We need a negative 3. You need a negative 3? Yeah, this biggest one gets the negative, right? Okay. Now let's do the other one. This one is difference of squares, right? So we have Z. 16 is 4 and 4, right? So you got plus and minus 4. The bottom, Z and Z. 36, they're going to add to give us 12. Did you already know what it is? 4 and 9? 4 and 9 don't give, 4 and 9 give you 13. What'd you say it was? 6 and 6, yeah,
Z minus 6, Z minus 6.
right. 6 and 6, and they're both negatives. Okay, so now we can do some canceling, right? Because it's multiplied, you can do any top, any bottom. What can we cancel?
Z minus 6.
Yeah, one of these, not both, either one, but not both. Next, minus 4. So on top we have z plus 4, z plus 3. On bottom we have the 2 and the z minus 6. It's usually just kind of natural to put the number in front. So is that right? Okay, everybody got it written down? Okay, find another one. These are, it scrambles them and it could be in any order, so I started writing them down and then I came and I opened it up so it scrambled the order. So I'm like, okay. Here's one that you need to add. Obviously add, because I'm going to put a plus in the middle. Adding fractions, you need what? Common denominator. We don't have anything in common. What are these things? They're switched around, they're opposites, aren't they? This is opposite of that. So if we multiply this times -1, I'm doing it on this one because we're going to have something in the factor on top. We don't want the negative in front of this, so I'm doing this one. If we do the bottom times -1, it makes it like the other one. Okay, so our common denominator is c minus d. On top we have c cubed minus d cubed. Remember, you can factor that, huh? We have a little thing, SOP, remember? When you're doing cubes, you have that SOP. Well, remember what SOP stands for, right? Same, opposite, positive, right? Okay, so let's put this back on the bottom. The same is going to be, when you have it here, this is the same sign as this, right? Okay, so same sign. The cube root of this is c, and you square it here, don't you? You put the cube root of it and you square it here. Okay? D cubed, you cube it here, and you square it here, right? The middle term, remember you have to multiply these? CD. Multiply those, it gives you the middle term. This is the same, the opposite, and positive. It's always positive right there. We're going to be able to cancel, huh? Boom, boom. So our answer is this part. So you may have to make sure and do that right, or you get the wrong answer here. Anytime you factor, you got to do it right, huh? That messes the answer up. Okay, let's multiply. Everybody got that written down? Okay, multiply. If you have v plus g times V squared minus VG plus G squared. Okay, you can go through all the steps. You can go through multiplying each one of these, multiplying each one of these, or you can recognize that this is V cubed. And remember how it's the same, opposite, positive. We know that this is going to be same. This is going to be a plus here. This is V cubed and G cubed. And if you recognize that, you don't have to do every step of multiplying and all the canceling. Kind of like recognizing a difference of squares, right? The difference of squares when you see minus 4 and plus 4, do you FOIL it, or do you say, oh, I know that's squared, this squared and that squared, right? If you recognize it, you don't do the multiplication. So if you recognize that, you saved yourself a step. We've done that one. Okay, a wire is stretched from the ground to the top of an antenna. Okay, here's our wire. The wire is 40 feet long. The height of the tower is 8 feet greater than the distance D of the base. So this is 8 feet more than how far it is from where the wire is attached to the base of this antenna. So what we're going to write here, 8 foot more, you have to put plus 8. We're going to use the what? Pythagorean theorem, remember? A squared plus B squared equals C squared. Using this as A and that B. So D squared, this squared, plus this squared, the two that make up the right angle. This squared plus this squared equals C squared, which is our hypotenuse. I don't think it's going to fit here because that's going to get long, isn't it? We're going to have D squared plus, that squared is going to have to be FOILed. D squared plus 8 plus 8 plus 16D, and then 8 times 8, 64. 40 squared, 1,600. One and one of these is 2D squared plus 16D. We want equal to 0, so let's go ahead and do that. Minus 1536. Yes? Okay. Let's divide everything by 2. So divide that by 2 real quick while it's still in there. 768. Okay. Okay, so we need to factor this. D and D. Okay, that's kind of tough, isn't it? It's going to take a while to do all these. When you have a number that has so many factors, you might want to prime factor it, and you can find the factors easier.
24, 32.
It is 24 to 32, but let's see how we're going to figure that out if you just don't, because then, hey, Will, could you figure this one out for me? Okay. Yeah. Yeah. Okay. You just did a few till it worked, right?
Yeah.
Okay, let's divide by 2, and we get 384? No? Why?
I'm just kidding.
Do it. Let's divide by 2 again. 192, divide by 2, 96, divide by 2, 48, divide by 2, 24. If you stop there, and oh look, you know, we can go 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 24. That one is 8 apart. You know, you could do it here, those aren't 8 apart. 4 times that's not 8 apart. 4 times 2 is 8, 8 times that is not 8 apart. You know, you could keep doing it till you find one that's 8 apart. 16 times that, no, that's not 8 apart. And then when we do that, 32 times 24, yes, there we go. Or you could break it all the way down till, I think you end up with only 1 3 at the end. It's like, no, 2, yeah, 1 3. But you could do that, and you see it's 24 and 32, right? Which one's positive? This one, and this one's negative, right? 2 equals 0 does not give us an answer. This gives us a 24. This gives us a negative 32. Is the distance from the base, this D here, can't be negative, right? So 24 is the distance of the base. And it's going to ask you both of the answers. First it'll want the D, and then it'll want what's the other one. So you don't give them at the same time, you're going to give the answer separately. You'll put one answer in, then it's going to ask the other answer. And you'll say how far is it from the base, then it'll ask how tall is the antenna. Okay? Am I giving you too much information? No? Okay. This one's the graph, you can do that. Moving sidewalk, you can do that. Envelope is longer than it is wide, you can do that. Okay, here's a different one. Find the domain of this function. F of x equals 6x minus 5 over x plus 8. Okay, the domain. Really? Okay. What does the domain mean? X's, what can the x's be? Is there something that an x cannot be here? It can't make this 0, right? So if we put this, it cannot be 0, because we can't make the denominator 0. So we say x cannot be 0. Okay? It's going to want it in set notation, set builder notation, and it's going to want it in interval notation. Set builder notation means the set of numbers of x such that x, and it already has this stuff written for you. It already writes that. I mean, it's like, you don't have to know what is set notation, because it writes this, x is a real number, and all you gotta do is put that part. Actually, not equal to the negative 8. It writes all this for you, and all you have to do is put that number right there. Okay? So you don't even have to remember what set builder is, because all the choices have x such that, okay? It says x such that it's a real number in this, and then it says it's a complex number, and it's a real number. But it has to be the one where it has one where you can say it's not something. Okay? So that should be pretty simple. How do you write that in interval notation? Remember? You start all the way at negative infinity, right? And you put a bracket or parentheses, and you go all the way up to -8. Oops! Negative infinity and negative infinity. And then we put the union and started at -8. Oh, it's positive infinity, right. So you'll have to type all that in, okay? And it'll give you a thing where you can put that, just like you did in your homework. Okay, what? It's stinking. Don't you love when computers stink? Okay. It says to use synthetic division to divide. I never did show you that. Do you have to use synthetic to get the right answer? We can do that other division, can't we? Okay. Actually, we should probably make sure we know the synthetic, because you're going to need to know it probably for your next class. So, we'll get into the book and we'll show you how to do synthetic. You want to look at it now?
Yeah.
Instead of doing that long division? Yeah? Okay. Nobody has a book, so they can tell me what page it's on either, do they? I know it's in chapter 4 or 5. That does a lot of good. Table of contents I thought would help, but they're being used in today. 4 or 5. Division polynomials is 5.3. Okay. Good synthetic. Okay. Synthetic division.
Well, it's kind of the same, isn't it?
It's kind of the same.
That's the one that's.
The only thing is you have a -2 here, you change it to positive. Okay? So, see how you have a -2 here? When you put it out here, you put it as a 2. Okay? Positive. And you put all the coefficients, the 4, -3, 1, and 7. 4, -3, 1, and 7. Okay? And then it says after the opposite of -2, you put it up here. Then you bring down your first number. Okay, you bring the 4 down. And then you multiply it times that and bring it up here. Then you add these. Bring that number down. Okay? Then multiply it times 2. Put it over here. Add those numbers. Okay? Multiply it times 2. Put it over here. And add those numbers. This will be your answer, but we got to figure out what to do with that. Okay? This 4, see how it was an x cubed here? It's going to be an x squared. It's going to be 1 less than this x here. Okay? So this will be 4x squared. This is a positive, so positive 5x plus 11. These are all positive, so it's plus. This is a remainder. So that will go over what we were divided by, x minus 2. Okay? So 4x squared plus 5x plus 11. The remainder 9, but they want it like this, not remainder 9. They want the remainder over what we divided by. Now let's do the one that I had. See if we can get it right. Okay, a minus 3, we're putting the opposite in the front. Opposite of this is a 3. Okay? So, coefficients, put your 1. -7 and a +7. So to bring this down, right? Multiply it, 1 times 3, and put it over here. 3. When you add those two, what do you get? -4. Okay? Multiply that. -4 times 3 is, wait, did we bring something down?
-12.
Yeah. -12. 5. Multiply that. Huh? -15, right? Actually goes right here. That's going to be our remainder. How come this one? I don't like it either. That's why I like the other way. It's positive, right? Okay. I did it wrong. Let's do it again. I know what to do now. I'm sorry I messed you up. We put the 3 out here. 1, -7, 7. That was right. Okay? 1, -7, and 7. Okay, so we bring this down, multiply it, we have the 3, right? That's 4. Okay. -4, sorry. Okay, we multiply that. You know what happened? I left something out here.
Oh, you gotta put in another
3, 2,
1.
there's a 0 A's, right? That's why it didn't work for us. We did the steps right, we just didn't have a 0 here. Because this is our x to the 3rd, x squared, or a to the 3rd squared, a term, and then our number. So that's what happened, I left that out. Okay, so -4 times 3 is -12. Bring that down. -12 times 3 is -36. Add that to 7 is what? -29. Now this, instead of being to the 3rd, will be our squared. Okay? Let me do a different color now. So it's 1a squared, or just a squared. That's our numbers. 1a squared, the next term will be our a. So -4a. The next term won't have an a. And then this is our remainder. Over, what did we divide by? A minus 3. I'm sorry, 29, yes. I'm so sorry. I think we should do another one of those, don't you?
Yes.
For sure. Okay. This is all written up. Oh, with dots all over the paper. Okay, let's go. Okay, let's do this one. A cubed minus 5a squared plus 8 divided by a minus 2. It did the same thing. So you can bet it's probably going to do that to you also. There's no a's in there. Okay, setting it up. Let's put the opposite of this on the outside. Right? Put our coefficients 1, negative 5, 0, and 8. Okay, it said to bring this down. Multiply, put it over here. 1 times 2 is 2. What does that make this? Negative 3. Multiply it times this. Negative 6. Add that, you get negative 6, right? 0 plus negative 6.
Negative 12.
Multiply this times this, negative 12. Add that. Negative 4. Okay, so this, instead of being a cubed, will be a squared term. 1a squared minus 3. After a squared, we have a. So this will be a squared, a, and no a, and that's going to be our remainder, right? That's our a, our number, and our remainder. So after you do it a few times, and it's not so bad. This is like, what? Okay? And if you want to practice some more, you can go back to 5.3 and find a problem that's like that on your homework, and you can practice it. If you want to practice some more synthetic division. We need to move on so we get everything covered up. Next question. This looks huge, but it's not. Okay. 2a to the 9th plus 10a to the 10th d7 plus 4a to the 4th d to the 4th plus 8a to the 4th minus 7. And it says the degree of 2a to the 9th is. It has all this writing. Is what? What's the degree? 9, the exponent. The degree of this? No. 17. You have to add them. All the exponents get added in each term. So the degree of that one is 17. The degree of this one?
8.
Right. 4 and 4 is 8. The degree of this one?
4.
And the degree of this one?
0.
Yeah. Okay? So the degree of this polynomial is what? You're going to have all your answers listed there?
17.
So you just go find your biggest what number? So the degree of the polynomial is 17, right? And it says, what is the leading term of the polynomial? Did we do a leading term?
10.
Yeah, the one that's this degree, the leading term of this is 10. Actually, the whole term. The one that's this, the leading term is this whole thing. Not just the 10, but the whole term. Okay? Let me see if there's more to this. Oh yeah. And And then the leading coefficient of this polynomial, this is the leading term. The leading coefficient is 10. Okay, did you do something like that on homework? Leading term and the leading coefficient? Okay. I'm gonna have to make sure I cover that next time, because I don't think I covered it. You probably had to view an example to figure that one out. Okay. Next problem, factor. We haven't factored one of these yet. Four s squared minus 12sd plus 9d squared. You see a common factor. That's what you look for first. No? Nothing in common, right? Do we have perfect squares anywhere? At the beginning and end? Okay, these are perfect squares, so that might help us to factor it. Let's try. This will be 2s and 2s. This will be 3d and 3d. Right? These 6 SD or DS and this 6 SD, they add up to the 12, but we need them to be negative because you have a negative 12, so we need both these to be negative. So it will let you write this one time with the squared and not have to write it twice. Okay, let's solve this. Solve capital B over small h equals L, capital L plus X over X. We need to solve this for X. How are we going to do that? Huh?
It's a H.
Yep. What do we know about if fraction equals a fraction? That's a proportion, isn't it? You can either multiply by the common denominator, and you'll end up with it. That'll, the common denominator is both of these, or you can remember that this is a proportion and that cross products are equal. So this times that is equal to this times that. So we have HL plus HX equals capital BX. Okay, so we don't have any parentheses. What are we solving for? We're solving for X. We need to get X on one side. It's on both sides right now. So let's get it over here. So we have H capital L equals BX minus HX. We need to solve for X, so we need to factor X out of this.
Factor with no
Put the X out here. It has an X in common. If you factor the X out, then the first term is B, second term is H. So the only step left is to get the X by itself, so divide by what you multiplied by here, this part, so it can cancel. There's your answer. It'll have x equals, and all you have to do is write HL over, well, I'm sure it won't be the exact same problem, but you just have to write this part because it'll say x equals for you. Yeah, here's the one that says f of x and find a, so the f of a is, I'm sure it'll word it the same crazy way for you. Okay, here's one. Did we do one of these yet? Maybe. Yeah, we did. It's like this one. Okay. Subtract, we've done that. Divide, we did that. The one that says to divide, you could either use that synthetic division. Remember when we did this one, it was divide? If it gives you this problem, we can do it like this, or use synthetic. If it shows you this problem, it's probably going to come out even. The synthetic division will probably come out with
I
a
have a question on that.
remainder. Yes?
We changed it from negative to positive, we put a -8.
Yes. If you do synthetic, put a -8. You know what that keeps you from having to do? That keeps you from having to change the sign here to add. If you put the -8 here, you know, we brought the 1 down. For synthetic, 1 times -8, it gives you the -8 without having to change it. So that's why you change that sign. Okay? So most likely if they give it to you in this form, it'll come out even. The other form will probably have a remainder. Okay, I think there's 2 more problems. Yeah, 2 more problems. Got dots everywhere, look like chicken pox. Okay, there's still dots. Maximum number of grams of fat, F. This is the grams of fat. That should be in a diet varies directly. Remember, directly and indirectly? These 2 problems are going to be a directly and indirectly problem. It varies directly as the person's weight. Okay? And then it says a person weighing, H-I-N-G, a person weighing 99 pounds should have no more than 66 grams of fat. That would be your F, right? So what is the maximum for somebody weighing 54 pounds? So there's our problem set up. Well, it's not set up, that's our problem handed to us. We need to set it up. Okay, varies directly means you do the K, and is it going to be multiplied or divided? Directly is multiplied. So normally you put like y equals kx, but we're not using x's and y's, are we? The first thing would be like your y. So the F varies directly as the W. Okay? And we need to find out what K is, so we're sticking these numbers in to find out our constant. Not consonant, that's an English thing, consonant. Find out our constant. Okay, so F is fat, W is 99. So divide by 99, right? K is 2/3, right? 6/9, which is 2/3. Everybody see how to do that? Okay. So, we're gonna put our original formula with this as our K. Right? And is this gonna be put in where the W or the F is? That's the weight. Right. So all we're gonna do is multiply it times 2/3, right? You can do that and get 108 divided by 3, or you can divide by 3 first. Divide by 3 is 18. Then 18 times 2 is 36. 36 grams of fat for a 54-pound person. Okay, so if it says varies directly, put F equals K times W. Next, the number of files in, this is files, the number of files of the same size, Z. N is the number of files of the same size that a computer's hard disk will hold. The number of files varies inversely we didn't need all those other words, did we? No. That varies inversely as the size S of the files. So S is the size of files, this is how many files of that size. Okay, so it says if somebody's hard disk will hold 1,600 files, it will hold 1,600 files if each file is 160,000 bytes long. Okay, so how many files will it hold if each file is 20,000 bytes long? Okay, varies inversely. N varies inversely, so you put the K divided by inversely as the size F. F is the. Okay, so we need to find out K. We need to put these numbers in these places that don't have K's. This is files, this is bytes. Which one was which? Which one's the N? N is the files, S is the size. This is how many, the size, how long it is. So this one is 1,600. And we'll put the K on top. S is 160,000. How are we going to find K? Multiply it. Right. That's going to be huge, huh? Got a big K there. So K will be 256?
256, yeah.
So K is that huge number. And it doesn't want anything except the final answer, so you don't even have to write that anywhere. It's just part of your work. N equals this over S. Okay? It's 256, in case you can't read it. So it says, if each one is this long, that's your size. Okay? So put the N, you have that big old huge long number, divided by 20,000. You can just drop 3 zeros off right there and just divide those numbers. 256,000 divided by 20 will give you what?
12,800.
Do what?
12,800.
1,800?
12,000.
Oh. 12,800.
800.
Yeah. That's how many files it would hold if they were 20,000 bytes long. And that's a little bit of everything. Any questions? You want to redo some of them? Is there one of them that you think, let's do another one of those? Because I could find, it'll give me an unlimited number of them if you want to do some more.
Do I take the test now?
Yes, yes. You go to Success Center and take it. Yes, you may. All the way up to the 10th of April, you can take the test. That's the Thursday before spring break. That's next Thursday. Don't let it get too foggy in your brain because we're going to be covering new material Monday and Wednesday next week. What are we doing? Look at our syllabus. What do you think we're doing?
Where's the syllabus?
You guys are so funny.